Probability, Chapter 5, Venn diagrams. A Venn diagram can be used to represent events graphically. Frequencies or probabilities can be placed in the regions of the Venn diagram. You'll note that quite often we draw a box around, potentially some interlocking circles, although they don't have to be circles, and sometimes you'll have two, or sometimes you could have three. Sometimes you could have three with one separated, and there are different combinations of these. You'll note that we have a capital S outside, and that represents the sample space. You may sometimes see it written as a curly E or a U, meaning the universal set. However, for this we'll focus on the letter S representing the sample space. If we think of the circles being A and B as two separate events, then it is possible that they overlap. So we think of the intersection being and. You may have seen this before as written as the probability of A intersect B. That is when we're using a probability combined with set theory. In the second one here, we have the event A or B. So notice it could be in A, or it could be in B, or it could be in both. So it is everything inside. And this can be thought of in terms of probability with this, the union of those. And in the third one here, we have the event of not, quite often referred to as the complement. And here we can see the circle A, and obviously the shaded bit is everything not in A, so the complement of A. Now the probability of everything inside the sample space represents 1. So therefore, what is inside A combined with what is outside A must total to 1. So we can think of the complement of A as being a dash, meaning complement, and that is the same as the total box minus the probability of what is in A. So looking at example 3, to deal with Venn diagrams. We have a class of 30 students, 7 are in the choir, 5 are in the school band, and 2 are in this choir and the band. So it's possible to be in both. So we can think now, or we're being asked to draw a Venn diagram. So drawing a Venn diagram, we have our sample space, and we can think of it being this representing the band, so I'm going to denote a capital B for that, and then we can think of another one representing the choir. We're told that 2 are in both. It's always best to try and start at the centre if possible. We're then told that 7 are in the choir. Well, if 7 are in the choir and 2 of them are in both, that means there must be 5 who are only in the choir. And if 5 are in the school band and 2 are in both, that means there must be 3 only in the band. We're then told that there's a total of 30 students. Well, hopefully you can see that 3 plus 2 plus 5 gives us a total of 10, meaning that we must have 20 students who are neither in the band or the choir. So now we have our diagram drawn, we can move on to answer the questions. So for part B, part 1, the probability that the student is not in the band, which could also be written as the probability of B dash. Well, at this point, you could think of everything in the band, and not that is everything not shaded in here. So the 5 and the 20 giving us 25 over 30, which simplifies to 5 over 6. For part 2 now. Here we want to find the probability that the student is not in the choir or the band. So you could write this out as a sentence, so not in choir or band. And for those who like notation, we could think of this as being, well, let's look at the diagram first of all. So not in the choir and not in the band, well, that only leaves the outside bit, which is 20. So we could write this one way as notation as B union C not. And this is equal to 20 over 30, which is clearly 2/3. in example 4, a vet surveys 100 of her clients, so the sample space total is 100, and she finds the following. Well, here we can see that we have dogs, fish and cats. We're not explicitly told to draw a Venn diagram, however, quite often you'll find it is very helpful to draw one. So, drawing our Venn diagram, and we have 3 different outcomes, so I'm going to assume that they will overlap. If any of the regions are 0, we can just put a 0 in and we'll label that an S. Okay, so now looking through the different values, 7 own dogs, cat and fish, so I'm going to put 7 in the middle. Next, we have 10 own cats and fish. Now, I should have previously we'll do dogs, cats and fish. So then 10 own cats and fish, meaning cats and fish should be 10, meaning we're missing a 3. Next, 11 own dogs and fish. So 11 own dogs and fish, meaning we're missing a 4. 15 own dogs and cats, meaning we're missing an 8. And next, 25 own dogs. So in total, here we have 25. So this means we're missing a 6. 53 own cats. So here we have 53 inside this circle, which gives us 35. Must only own a cat. And finally, what are we missing? Well, 40 owned fish. So in this one, we must have fish. So therefore, 26 must go here. Meaning that if we total all of those up, we realise, let's just look at that, if we total everything inside all of the circles, we get a total of 89, meaning that 11 must go on the outside. So just be systematic and fill them in. We could, of course, have written those differently. We could have written them all as probabilities. So, for example, the 6 could have been written as 0.06, and then you have the corresponding probability for each region. However, many people prefer to put the frequency in first. Okay, let's go to actually answer the question. The probability of dogs only. Well, in our diagram, dogs only, as you can see, is 6. So that is 6 out of 100. And if we want to write that as a decimal, that is 0.06. For part B, does not own fish. So not fish. And if we look here, we could think one way would be to find, well, how many are there in fish? And we realize that's 40. So not must be 60. As a decimal, 0.6. And C, does not own a dog, cats, or fish. So not dogs, cats, or fish. Well, at this point, that's just, it's not inside any of the circles, so it must be the 11 which is outside. So 11 over 100, which is 0.11. And we have our answers.